Hello and welcome to Math Albatroa today. Today we want to consider this question on latitude and longitude. And the question says two ships on the what? On the equator are on what? On longitude 45 degree west and 45 degree east respectively. Let me bring the question to this side so that I can underline some of the important information we have. So two ships on the equator are on longitude 45 degrees west and 45 degrees east. Okay, so look at this, please. Look at it. Equator, very important. Now let's go. Now, how far are they apart along the equator? Correct your answer to two significant figures. This is also important. Then they say we should take the radius of the earth as 6,400 kilometers, and we take the value of pi as 22/7. Now, just by mere seeing equator in the question, just by mere citing equator in the question, we are going to say that the distance between the two ships they are talking about, distance is going to be equal to theta over 360 multiplied by 2 pi capital R. The capital R is what they are calling radius of the earth. We put out value of the capital R for it here. That's radius of the earth, 6,400 kilometers. So let's go. All right. Now, one important thing I want you to know is that the equator is a great circle. Equator is a great circle. Equator is a great circle. A great circle has radius radius that is the same as the radius of the earth. Radius of a great circle is equal to that of the radius of the earth. If the radius of a particular latitude is smaller than that of the radius of the earth, we say that the latitude is what? Is a small circle. Okay, so this is the formula we have. Now let's see how we can get all the parameters we have here in order to execute, to evaluate this. Now, so I said that equator is a great circle. Before we finish, we continue with the evaluation. Now, all lines of longitude are also great circles. All lines of longitude, all lines of longitude, all lines of longitude are also great circles. All right, all lines of longitude are great circles. As time goes on, in another video, you will know why it is like that. Okay, now let's go. Now, how do we find the value of theta and all of this other information? We already have the value of pi, we have the value of capital R, is remaining theta. So look at how we answer that question. We'll come back to the question and look at it. They say longitude 45 degrees west and then what? 45 degrees east. So we're going to say we can represent the two ships like this. We're going to write 0 degree, comma, and then you write that first one there is 45 degrees west, and then the second ship represented like letter B. We have 0 degree, and then the latitude is 45 degrees, but towards the east this time around. All right, so the value of the equator is actually latitude 0 degree. If you see latitude 0 degree, is another way of representing equator, latitude 0 degree. Okay, all right. So now, how do we find theta? Now look at how I show you how to find. Just follow as I show you how to get the value of theta. Now, if you check very well, we have 0 degree, entirely the same. This is nowhere to find your theta, which is the angular difference. The name for theta is called angular difference. Okay, now so the things that are entirely the same, you cancel them out. Please, I am not saying, even though you have 45 degrees, but the directions are different, meaning that they are not the same. We have 45 degrees west, 45 degrees east. You will not cancel them. 0 degree, we cancel them. Now, so because one point is toward the west and the other point is toward the east, we are going to add to get angular difference. So we are going to say 45, the first 45 plus what? Plus the second 45, which will give us 90 degrees as the value of our theta. Now, if they are towards different, if they are towards the same side, we would have subtracted. What I mean is that supposing we're having like point A as latitude 0 degree, then let's say 75 degree, let's say west, and then let's say we're having point B as 0 degree, and then let's say 45. Let me just create another thing. Let's say 40 degrees. Let's say the stem west. So for you to find angular difference, supposing we're having this, after you cancel latitude 0 against latitude 0 degree, if you check very well now, they are towards the same location, west and west. So in this case now, you will say theta is equal to what? The bigger value minus what? Minus the smaller value, to avoid getting a negative answer. So this is how we handle a question of this type. So this one would have given us 35 degrees as our angular difference. But because they are towards different location, where we decided to add. That's the rule. If they are towards the same location, you are going to subtract the smaller one from the bigger one. But if they are towards different location, we add. But if they are towards the same location, we say the bigger value minus the smaller one. That's how we solve question on latitude and longitude. Okay, now let's go. All right, so let's go. Let me use another color. Okay, now let's go. So we have all that we need. So this is our theta. Capital letter R is what we call radius of the earth. We have the value as 6,400. Then pi is given to us as 22/7. Now, so we can now use the formula now to finish up the work. We are going to say distance between the two ships, which used to be theta over 360 multiplied by 2 pi capital R will now become, instead of theta, we are going to write 90 over 360 multiplied by 2 multiplied by pi is 22/7, and then capital R is 6,400. Okay, so here 0 can cancel 0. Now 9 is a factor of 36, so you can go. So 9 here, you have 1. How many 9 can you see in 36? You have 4. Okay, now so what do we do now? We're going to have 2 and 4 are connected. So 2 here, 1, 2 in 4, we're going to have 2. Another this thing again is that 2 and 22 are connected. So 2 into 1, how many 2 in 22? 11. So what remains will now be 11 multiplied by 6,400, then divided by 7. Okay, so let's quickly do that. So I have a calculator here to enable us evaluate it very, very quickly. So we have 11 multiplied by 6,400. So we are going to get, then we divide it by 7. So divided by 7. So we're going to have, our answer is going to be 10,057.14286 kilometers. But please, you remember, if you go back to the question says you should leave the answer to 2 significant figures. Look at it. Leave the answer to 2 significant figures. So we return and then we leave to obey the instruction. We leave the answer to 2 significant figures. All right. So 2 significant figures means just start your counting from the left hand side and be going from the left hand side. So this is 1 and this is 2. So it's like you put a boundary line and then you look at the nearest number here is 0. So 0 is just 0. So you run it down. It's already 0. So everything, the answer will now become 10,000. All right, 10,000 kilometers. That's to 2 significant figures. So 10,000 kilometers is the correct answer to the question. Okay, in case you want to sketch, in case you want to sketch the diagram of that, of what we just answered now, it's going to look some maybe like this. we have a circle now. So you're going to have we have a circle now. So we're going to have a line coming from up to down. You can call this line, this is north, this is south. All right, this is north and south. Then you're going to have another one this way. So you have east and then you have west. So you just use a curve to represent equator. This is a curve. Please, equator is a circle. Every line of latitude is a circle. Like equator is a circle also because it's a line of latitude. But to avoid confusion, we just use a curve to represent equator. So you can tag this one as equator. Equator. So it is when you have equator, so the path towards up of the equator is towards the northern hemisphere. The one below the equator, if you go down on the equator, is towards the southern hemisphere. Okay, so they said 45 to the west. So this is west, this is north, this is south. Now west, this is west. So we have a line of longitude coming like this, 45. Tag it as 45 degrees west. 45 degrees west. Now we have another line of longitude rather, going towards the east. We have something of this nature. All right, so you label it as what? As 45 degree what? East. So the point they are talking about is the point of intersection. So here and this other here are where the two ships are. So we use letter A and letter B to represent them. I don't know if you are following. Now, for you to get the angular difference, you just from here, you link it to the polar axis. This line coming from north to south is what we call the polar axis. You link this one also to this place. So the angle you have here now is what we call theta. Is that okay now? All right. Thank you very much for your attention right from the beginning of the class down to this point. So let me give you something to do now. Please ensure you do it. All right. So these are the positions. Remember, 0 degree means that the 2 points are on the equator. So just by seeing equator in the question, use the formula theta over 360. Distance is equal to theta over 360 multiplied by 2 pi capital R, where capital R represents the radius of the earth. Thank you very, very much for your patience. Thank you for watching this video to the end. Please do well to like, to share, and subscribe. Please do something. Tell somebody about Math Al Batwa.